Okay, hi everyone. So we're going to continue graphing today, but this time with phase shift. And that's how we're going to include C. So graphing, sine and cosine, and this time with C. And this is a big jump. Hopefully you found A, B, and D easy to do. So let's do those first, and then we'll incorporate our phase shift. So graphing from before, last time in Mr. Ko's class, if we said y is equal to 2 sine of, let's do 1/2 x plus 1, okay? So we've seen this, very similar values, nothing new. First step is to label A, B, C, D. A is 2, B is 1/2, C is 0, because no parentheses, no C, and D is equal to 1. And we talked about graphing it from right to left. Step 2 is start graphing from right to left. We do our D value first, which is up one step, dot, 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 dot. Okay, once you get good at this, you should be able to graph graphs in like 30 to 40 seconds each. Just like as slower than you would graph a line, but the same type of work. Okay, that's our D. Our C value means we're starting at 0. So the graph is going to look something like this. But we don't know, is it going to be long, is it going to be short? So we need to graph our B value now. B tells us how long it takes me to finish one graph. So P is equal to 2 pi over B. And remember, that's our period. That's P equals to 2 pi over 1/2. We don't like dividing fractions. Please remember that. We multiply by the reciprocal instead. That's 4 pi. So it takes me 4 pi to finish this graph. Starting at 0, ending at 4 pi. We draw half, half, and half on my axis, okay, on my axis first, and we copy these values, tick, 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 and tick, onto my D value. We can label our axis if you want. Half of 4 pi is 2 pi. Half of 2 pi is pi. We count 1 pi, 2 pi, 3 pi. So we have it labeled if we need it. We did D, we did C, we did B. We only have one thing left. That's going to be A, up 2, down 2. I draw the dotted lines. I like them. It helps me out. When you're graphing on IXL, you can't draw the dotted lines, sure. But in your notes you can, and it reminds you how high and how low does your graph need to go. So starting for sine, we start at 0, 0, up, 0, all the way down, back to 0. When I say 0, I really mean my D value. That's the new axis I'm on. Go up, stop, down, stop, down, stop, up, stop, and then we just draw little angles over. If I want to graph cosine, y equals to 2 cosine of 1/2 of x plus 1. The A is still 2. The B is still 1/2. The C is still 0. The D is still 1. All the characteristics, all the framework is still the same. The only difference, does anybody remember what the only difference is with cosine? Instead of starting at 0, where do we start off at? It's like a V shape-ish, right? So we start off at the amplitude. Start at amplitude. Okay, so we start all the way at the top. If it's a positive cosine, we start on the top. And then we walk our way down our slide. Middle, down, 0, up. And then we're back up. And this graph again continues this cycle forever. Continues the cycle. So if you can graph cosine, so if you can graph sine, you can graph cosine, and then vice versa. It's all the same basic structure for sine and cosine. Okay, so let's go ahead and continue with our C value. Our C value has been 0 for the longest time. So let's give you guys an easy one. Let's say y is equal to sine of x plus, let's say pi. And that's it. Label your A, B, C, and D. Now be careful here. I wrote a plus pi. Our standard form is a sine bx minus c plus d. And a value is 1, b is 1, c is negative pi, and d is 0. Now, what are we doing here is we are resetting our starting line. Okay, we're resetting our starting line. If you have a C, that means it's what we call a phase shift, right? So this is going to shift my graph to the right or to left. And negative pi is great, but we can't just take it, actually. So what happens is our x value is C over B. We have another fraction that we have to work with. It's C over B. So that's going to be negative pi over 1 is negative pi. I'm going to talk about why we have to write C over B in a little bit, but that's a formula that we always use to decide where we're going to start the graph. Okay, starting from D and work our way backwards. Okay, start from D. D is 0, done. This graph is right in the middle on the floor. C is going to be negative pi. Here's negative pi in the back. So this is our new starting value. It's like I took the graph and I pulled it backwards, almost like a bow and arrow, right? I'm pulling my bow back, so the string is at 0, it's at negative pi. Now that we pulled our bow back, our b value helps us find p, 2 pi over 1. That means we have to end at 2 pi. 2 pi, not 2 pi here, but 2 pi away from where we started from. If we start at negative pi, 2 pi would take us to pi. Now, to show you some steps how to do this, to find where we end, we say we take our x value and we plus our period. Our x value is negative pi, and we plus our period, which is 2 pi. 2 pi minus pi, which is pi. So this is where we end. This is our start. This is the period. And this is where we end. Half, half, and half. Please notice that I'm still doing half, half, and half because I need to give my the spread. Half, half, and half. And then the last part is amplitude. We did D, we did C, we did B. Now we still have to do A. A is amplitude up 1, down 1. Okay, from here on, this is a sine graph. So sine starts at 0. Let's go ahead and graph it at 0. 0, up, 0, down, 0. Sine graphs will always have this pattern of going up first and then going down. Why? To repeat this, these are the y values of a circle. So look at a circle. If I start at 0, when I go to my first point, call that 1, 2, 3, and 4, okay? So to go to 1, we went up, then back down to 0, then negative 1, then back down to 0, back up to 0. 0, up, 0, down, 0. 0, up, 0, down, 0. 0, up, 0, down, 0. 0, up to 1, back to 0, down to negative 1, back to 0. 0, up, 0, down, 0. We're just really following the flow of the circle. Okay, let's do another problem. Let's do one with a b value being 2. A is 1, b is 2, c is negative pi, and d is 0. So a, c, and d haven't changed from our previous example, but our b value has. And if you remember what b stands for frequency. And that might not mean much to you, but if I tell you to take 1 pill a day, that's a frequency is 1. But then if I tell you take 2 pills a day, wait, that means the period has been cut in half. 2 pi over b is now pi. That means we can squeeze in more iterations. So these graphs get smaller or longer. When you want to squeeze things in more, each of the graphs gets smaller. Example, imagine if you only had one homework. That means you could spend all night on it if you really wanted to. But what if you have 2 homeworks? That means you have to divvy up that time now. So you can spend less time with the homework. What if you have 4 homeworks? That means you can even spend even less time with each homework. Doctors have to do this. Doctors used to have a lot of time when they had to see the patients, 10 minutes, 20 minutes, 15 minutes, depends how you scheduled it. Nowadays, they're scheduling appointments that you need to see 20 patients in 1 hour. How do you see 20 patients in 1 hour? It's by giving them only 3 minutes each. Okay, so that's what we're doing. We're going to shrink our graphs. So we're going to do everything like we did before. Okay, don't freak out. Start from D and work our way backwards. Okay, so starting with D, we see D is 0. That's a freebie. Yeah, I like freebies. So D is 0. That's the center of my graph. C. C is not my phase shift. C helps me find my phase shift. My phase shift is X equals to C over B. My C value is negative pi. My B value is 2. I'm starting at negative pi over 2 now. Negative pi over 2. But didn't we start before at negative pi? Now here's the reason why. Anyone ever shrink their clothes in the washer or in the dryer? Right? Shrinks. So everything shrinks. I want you to look at this. If I take my graph from here to here, from here to here, and I shrink it, okay? Everyone, I'm gonna shrink it, right? It's gonna squeeze together, right? Imagine if I said shrink it by half the size. We used to start at negative pi, but if I shrink it, doesn't the graph start at pi over 2 now? Because we shrunk it. And that's what happens. By shrinking your period, you actually change the position of your new starting phase shift. Sure, we should have started at negative pi, but because the graph shrunk, it pulled the starting value closer together, tighter. Yep, thank you, Roman. You know how to wash your clothes properly. But you can agree with me that when things shrink, it messes stuff up. Now, the example of the doctor's appointment is this. Imagine if your doctor's appointment was at 12 o'clock and their appointments in front of you became shorter, right? She was able to squeeze more people in. Can't she take you in a little bit earlier? Because the periods of appointments have shrunk, she can now take you earlier. But what if she's taking too long with each of her patients? That means it's going to push your appointment start time later. Because as the periods get longer, we get pushed out. But as periods get smaller, we get pulled in essence. Okay? And that's what we have to account for. Sure, we might have a starting value of C, but it changes depending on everyone else's appointment. And that's what the B value is. If appointments are shorter, your appointment time is actually shifted over, either earlier or later. And this is why we need the equation X equals to C over B, because it depends on B. Is B going to take too long? I hope not. So what happens is we have to use this equation here. This is a must, negative pi over 2. Then we follow, okay, we got D, we got C. This is our starting point, right? Ding, 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 ding. Here's our starting point. X equals to negative pi over 2. That's my starting point. Now, no problem. Now our period is pi. Remember, we used to be 2 pi long. But now we're pi long. So we're shorting out. So how do I get from negative pi over 2 to pi? How do I get from 50 cents and I add $1 to it? If you're not sure, we are at negative pi over 2. We're going to add pi. Okay, this is where we're going to end. This is my start. This is my period. And this is where we're going to end. Getting common denominator, 2 over 2. 2 minus 1 is pi over 2. We're going to end at pi over 2. And pi over 2 turns out to be right here. So not only did we start earlier, but remember the graph also got skinnier. Because instead of taking a full 2 pi to finish, you have to finish faster, pi. Okay, let's continue this. Half, half, and half. Remember we do our tick marks? Let me do that one in red if you want. Half, half, and half. That always helps me, I guess, what is it? Pace my graph a lot better. I want to make sure I pace it out right. Half, half, and half. And then last one is amplitude, A. And we said A was 1. That has not changed. 1, negative 1. So now we have our structure of our graph, though it is a lot skinnier. Where does sine start off at? Does it start at the amplitude or does it start in the middle? Starts in the middle. 0, thank you. In this case, it's going to be perfectly 0 because there is no d value. 0, up, 0, down, 0. 0, up, 0, down, 0. And this is our graph shifted to the back because we had a c value. This is a graph that only takes pi to finish, which is our b value. The amplitude is up 1, down 1 with a center of d. Now, what if you want to keep drawing this? The trick is just keep your tick marks. This is 1 tick mark, 2 tick mark, 3 tick mark, 4 tick mark, 1, 2, 3, 4, 1, 2, 3, 4. Just keep the same pacing, right? Because you already know what each tick mark looks like. We just follow the pattern. Oops. Yep, that's right. Don't skip any. Sometimes I end up forgetting and I start skipping. Okay. Okay, we're going to do a couple more problems like this with the shifting. Okay, let's do cosine. Let's do 2 cosine of, let's do 1/2 x. We'll do minus pi. And then we're going to add 1. Okay, so we have A, B, C, D, everything. This is a combo problem. If you can graph this and you understand where all the parts are, you are in excellent shape. Okay, A is equal to 2, B is equal to 1/2, C is equal to positive. Why? Because it's bx minus c, and the negative is already there. And d is equal to positive 1. As we graph this, don't overthink it. Just go d to a, and we'll work each part separately, okay? Each part is a separate component to different characteristics. It's like picking a pizza. What size do you want? Okay. Do you want extra cheese? What toppings? Vegetable toppings? Meat toppings? Oh, I forgot the crust. What type of crust do you want? Right? All these are different aspects of the pizza that when you put them together, you end up with your little masterpiece there. Blaze pizza. Yum. Too expensive for me though. I haven't eaten Blaze in a long time. Why? Okay, whoops. So let's go ahead and graph our graph. Our D is 1. It's nasty. Maybe nasty expensive, sure. I eat a lot of Domino's because they're pretty cheap. Yeah, I agree. Not complaining about that. Okay, all right. You guys are crazy. Picking random letters. Okay, we did D, C. Remember, C, you can't just say, oh, Ms. Crow, that's pi. Let's do it. No, because it's affected by B. Okay? It's affected by B. You guys ever call one of those, you try to call the phone company or the gas company or your cable company, and they say, your wait is 4 hours. Your estimated time, right? That 4 hours is just a guess. But if every person in that line takes an extra 10 minutes, you could be there all day. Not an adult. So here we go. To find out where we start, x is equal to c over b, which is just copy it, pi over 1/2. We don't like dividing fractions. We multiply by the reciprocal instead. 2 over 1 is just 2 pi. What the crap? We're starting way over here at 2 pi? That's a weird way to start. But hey, that's what the math told us. It said start at 2 pi, start at 2 pi. That's where I'm going to start. This is where the graph starts. Man, those previous appointments went too long. And it's true, they went too long. Because p is equal to 2 pi over 1/2. And that means, man, you took way too long there. 2 pi times 2 over 1, the reciprocal, and that's 4 pi. Each appointment took 4 freaking pi. You only get 2 pi. Why are you taking double the time? So that means if we start at 2 pi and we have to end 4 pi later, 2 pi plus 4 pi is way at 6 pi. I gotta wait till 6 o'clock to finish. And that's how you should feel when you start homework late, you end late. So how am I gonna get to 2 pi? If the first mark is 2, then this is gonna be 4, and this is gonna be 6 pi. Okay, so I'm trying to keep it relative to the tick marks I have. Okay, keep it relative to the tick marks I have. Okay, so we're starting at 2 pi and we're ending at 6 pi. All right, we're kind of cool with that. Half, half, and half. Here we go, half, half, and half. Half, half, and half. This is how we keep our graph nice and balanced. If without this, you might be like, whoa, I was just trying to squeeze it all in there. So we did, if you want to do the marks, what's the halfway point between 2 and 6? That's 4 pi. Half between 2 and 4 is 3 pi. 3, 4, 5 pi. Where did I get 2 pi and 4 pi? Okay, so x here is our starting value for c. This is our phase shift. And that's done by c over the letter b. So copy c over b. And that gives us 2 pi. That's how we got the
No, Mr.
starting
Crump,
value.
about the p for p.
Okay, so the p value is 2 pi over b, right? And the b that we said was 1/2. 2 pi over 1/2. Do we like dividing fractions?
Oh, so we always use 2 pi for p?
2 pi over b.
Yeah,
Yes.
but oh, okay.
Always.
Okay.
It's like me saying a day is 24 hours. On Earth it is. Maybe not on Mars, but on Earth we are. Okay? And times 2 over 1, that's how we end up with 4 pi. That's how we end up going from 2 o'clock and finishing all the way at 6 o'clock. Gosh, this takes forever. I'm just kidding. All right, let's continue this. We did D, right? We did C, we did B, and now we just have to do A, which is up to, and down to. So again, I draw these little dotted marks. I find them easier for me to draw. Might look a little messy for you, but these are my little border marks. And now we can start drawing our graph. This is a positive cosine graph. So positive cosine means we start on the top here. Everyone take a look here. I did not start in the middle. That is sine. And we don't have sine, we have cosine. So we start all the way at the tips. First tick mark, we go all the way to the middle. Then all the way down, back to the middle, and then all the way back up. You have to make sure you hit all the points. Every tick mark, we made these tick marks ourselves. These are our stopping points on the way to Vegas. And then we can complete it by drawing our curve. If you guys are still confused, I would say just watch this video again, one more time. Now, you can't just leave a graph hanging there in the middle. What about before and after? What about before and after? And that's what we need to go ahead and fix here. Let's look at what happens before. Is it just one big jump here? No, look at the tick marks. The tick marks that we drew already are every, look, I can squeeze another tick mark here. Okay, that's going to be pi, a tick mark. Going backwards, you can squeeze as many tick marks, balance this out as much as you can to make it look nice. So every tick mark takes another step, another step, another step. Careful, kids will do this, no joke. They will miss the center. Is this the center? Nope, not because we shifted up to D is 1. So please be careful. That's my center. And then back up. And really, we're just following the pattern. Once you get that first graph out, the rest is just following that same flow with the same distribution. Okay. And that's the idea, really. That's what it is. Okay, let's do one more, and then this will be our last example. Y is equal to 1/2. Let's do sine of 1/3. This one is ugly, okay? I did on purpose. X minus 2 pi over 3. I don't like myself either. Plus, I know we'll do a 0 there. Okay, so let's label our A, B, C, and D. I sound tired of hearing you guys complain. B is equal to 1/2. Oh, B is 1/3. Oh my gosh, why did I choose 1/3? C is, I do have a parentheses, and it's going to be 2 pi over 3. Right? So I'm just taking, I'm copying it. I'm not overthinking it. I'm just copying because that's what I'm supposed to do. I'm just kidding. Please make sure you do think about what you're doing. And my D value is no D. And we graph from right to left. The evil world we live in. Evil world where math solves all our answers. Balance the budget, math. Fix healthcare, math. Here we go. So we graph our line. This is our setup. Our D value is 0. Yes, that's right in the center. Our C value, did we just graph 2 pi over 3? No, because stupid appointments took so long. 1/3 is really bad. 1/3 means, oh my goodness, took you forever. So here we go. We're going to say 2 pi, x is equal to 2 pi over 3 divided by 1/3. Do we like dividing fractions? Nope. Mr. Ko picked it for a reason. Times 3 over 1. Bam, bam. We are done with 2 pi. Great. Thank you. 2 pi. So here's the important part about this. If there was no b value, if b was 1, we would be at 2 pi over 3 right here. We would be. Okay, we would be here. This is where we would have started. But because b was 1/3, let's write this. P is equal to 2 pi over 1/3. That means it took you a super long time to finish one freaking homework. That means this is 6 pi if you multiply by the reciprocal. 3 times 2 is 6. That means it took you, instead of 2 pi to finish, it took you 6 pi to finish. That means we had to push your appointment time way later. Okay, so that's what happened here. We should have been at 2 pi over 3, but because we had a b value, it pushed our value out. My appointment was at 2:30. I'm sorry, now it's 2 pi. We've been backed up, been busy here. So I need to erase this now. So now we're starting at 2 pi. How do we get 2 pi? X equals to c over b. And then, okay, let's graph our period. If we start at 2 pi and we end at 6 pi later, it's not 6 pi here. No, it's 6 pi from when you start. Okay, so if I started at 2 pi, x is 2 pi. If we add 6 pi, we end up with 8 pi. You have to stop at 8 pi. Oh my goodness. So this is 1, 2, 3, 4. 2, 4, 6, 8. We have to stop way over here at 8 pi. Because the graph got dragged on so long Because let's refresh ourselves. B stands for frequency. And frequency means how many times you see it. Imagine for homework, if I said you in one 24-hour period, you only finish 1/3 of your homework. That means you have to spend 3 days doing your homework. It dragged it out. So hopefully you guys can see that the period got extended because the frequency was small. That means the period takes a long time. Oh my goodness, see how far that is? Half, half, and half. Half between, what's the halfway point between 2 and 6? If you're not sure how to do 2 and 8, if you don't know how to do halfway, you say 2 plus 8 is 10. Halfway between 10 is 5. That's 5 pi over here. Half, half, and half. What's a halfway point between 2 and 5? I don't know. 2 plus 5 is 7. 7 half of 7 is 3.5. That's 3.5 here. 3.5 pi. 3.5 pi. And then if we're counting, what's a halfway point between 5 and 8? 5 plus 8 is 13. Half of 13 is 6.5. So 6.5 is halfway, 6.5 pi. So this one is a little bit messier. Okay, it is a little more messier. Uh-oh. Okay, so just to make sure you guys can see these tick marks, starting, ending, half, half, and half, right? That looks like half, half, and half. It isn't nice and perfect. It's not 4 pi. It's not 6 pi, right? It's 6.5 and 4, 3.5, right? They're a little bit off, but that's okay. I don't care about the rest. I can just erase it. We need our 3.5, and we need our 6.5, and we need our 5. So we did D, bam. We did C, bam. We did B, yes, we did. And now we only have A left. And our A value is 1/2. I'm gonna draw this nicely. If this is 1, this is -1, 1/2 is right in the middle. That's why these can get really messy, because in the real world, not everything follows nice solid numbers. I mean, everything you buy at the store does. 2 pairs of socks, right? 1 Nintendo Switch with 2 controllers, which really is 1 controller. Sorry, not complaining. Sine is 0, but 0. 0, first tick mark up, second tick mark coming back down, third tick mark coming all the way down to my amplitude, and then back to 0. Our graph is a muted one. Now, here's the tricky part. Where does this graph go? Well, if you're not sure, we know one loop is from 2 pi to 5, right? Isn't that 3 pi across? So if I go back 1, 2, 3, we're actually back here at negative pi. It would take us half. We would go like that. And that kind of looks balanced, right? My work I did. Oh, darn it. I went to 1/2 over here. Okay. So if you need more help, watch this video again. I'll go through all the steps I did. Now, the steps I showed you are the steps that I do all the time. I graph D, C, B, and A, and that sets up the structure, and then we decide if there's a sine or cosine to fit between the graph. Now your homework, you're gonna go up to 90% on both of these, and they will include a C. So this came out, no, you're right. And the point is that it's not always gonna come out pretty, but we stuck to the rules. We did each step very carefully, and we still got a graph that looks right. Okay. All right. Thank you very much. If you guys have any questions, you guys stick around. I'll be here for another 9 minutes. And if you need me to do another problem, let me know. If not, you can always email me. But I will say get started on the IXL, okay? Thank you.